Hey everyone, welcome back to the era of tech. Last time we have seen the Arduino terms, but today in this video we are going to explain all the pins and features of Arduino boards. Not just the Arduino, but Arduino in general. Whether you are using an Uno, Mega, Nano, Leonardo, Duo, Due or MK Arabot, the pin categories are basically the same, and understanding them clearly will help you use any board with confidence. Let's jump right in. Every Arduino board has a few core features in common. There is the microcontroller chip, which is the brain of the board, a power regulation section, a set of digital and analog pins, and communication interfaces. Depending on the board family, the operating voltage is usually either 5 volts like the Uno or Mega, or 3.3 volts like the Due or MK R series. You can power the board using USB, VIN pins, or a DC jack. And all boards support at least UART, SPI, and I2C communication. Let's begin with the power pins, which supply and regulate voltage. VIN allows you to feed external voltage, typically between 7 volts to 12 volts. The 5 volt pin gives you regulated 5 volts, or on some boards it can be used as an input. 3.3 volt is for components that run on a lower voltage. GND or ground pins provide the ground reference for the entire circuit. Reset can restart the microcontroller when pulled low. Newer boards may include pins like VUSB, VBAT, or VBAT, or 5 volt EN for more flexible power operations. Next are the digital pins, used for basic high and low signals. The number of digital pins depends on the board. For example, the Uno and the Nano have 14 digital pins. Mega 2000 and Mega 2560 has 54 pins. Leonardo has 20 pins. MK other boards have around 13 pins as well. Some digital pins have extra capabilities. Pins marked with a tiled support PWM, which is pulse width modulation, which lets you simulate analog outputs. Some pins act as external interrupts, allowing your program to respond immediately to signal changes. Others are reserved for serial communications. For the serial communication, SPI or I2C, depending on the board. Then we have the analog pins, the bread A0, A1, A2, and so on. These are connected to the board ADC, analog to digital converter. On the most AVR based boards like Uno and the Mega, the ADC has 10-byte resolution, giving values from 0 to 1023, 0 up to 1023 or 1023. On boards like the DU or MKR series, you will find 12-bit or higher resolution, offering more precise measurements. Analog pins are used to read sensor signals like potentiometers, temperature, light sensors, and in most boards, analog pins can also be used as digital pins if needed. For analog output, most boards rely on PWM pins, which rapidly switch between high and low to create analog-like voltage. Boards like have 6 PWM pins, Mega has 15, and the Leonardo has 7. Some boards like the Arduino Duo include true DAC pins that output real analog voltage, useful for audio and precise control application. All Arduino boards support communication interface. UART or Siri uses RX and TX pins to communicate with computers or other devices. Some boards like the Mega offer multiple UART ports. Next is SPI uses MOISI, MISO, or SC and SS pins for fast data transfer with modules like SD cards or displays. ICSP uses just 2 wires, so that sometimes they called TWI or TWI. SDI and the SCL allowing you to connect multiple sensors on the same bus. Some boards like Leonardo, Micro, and the MKL have a native USB support, meaning they act like a keyboard, mouse, or serial device without using traditional TX and RX pins. Some boards include these special pins for advanced features. The AREF pin lets you use a custom reference voltage for analog readings. SWD or JTAG pins on ARM-based boards, allowing for debugging and low-level programming. VBAT pins on some MKR boards power the real-time clock. These features vary from board to board, but the overall structure is consistent. So, in a few words, every Arduino board has a power pins for voltage and ground, digital pins for logic signals and special function like beta, PWM or serial, analog pins for sensor readings, PWM and DAC pins or DAC pins for analog output, communication pins for UART, SPI, and ICSP, and some special pins for advanced tasks. Once you understand these categories, you can work with Arduino model without confusion. And that's a complete overview of all Arduino pins and features in one guide. If this helped you understand your board better, hit that like button, subscribe for more tutorials, and comment below to tell me which Arduino board you use the most. Thank you for watching, and I will see you in the next one.